So once we have talked about the correlation, now we are in a position to discuss about the regression. So guys, when the variables are correlated, when the two variables are correlated, I told you about the variables, right? On the y-axis there could be one variable and on the x-axis there could be one variable. I told you the correlation we are talking about. If we are talking about, then we are talking about which graph? We are talking about the scattergram or scatter plot, right? So when two variables are correlated, right, then we shall be using the regression. How we shall use this particular technique termed as regression? We can actually use it for for the prediction part. Actually, we are predicting the what we are predicting basically in the regression. So if the MCQ comes, what we are talking about particularly in as far as regression is concerned, then your answer should be that you are expecting something. You are you want to predict something. So what we are predicting over here, we are predicting the value of one variable from the value of other using the regression technique, right? What I am talking about regression, I am saying that when variables are correlated, right, when variables are correlated, right, the value of one of the variable, right, the value of one of the variables can be predicted from value of another one, can be predicted from value of another one, right? Okay, and that will be termed as regression. So using which technique over here? Using the regression technique. Okay, so that is the basically regression. Okay, for an example, if this is the graph, right, this is the y-axis, this is the x-axis. On the basis of that, once in the correlation I told you about one thing, that was coefficient of determination, where I told you that if the x is changing, then we can anticipate the change in y. That was the determination coefficient, that was r square, right, coefficient of correlation square. But here we are talking about that one when variables are once correlated, after that if value of one variable we have to predict. So for example, I want to predict the value of y, so I can predict that from the value of x. Okay, so that is called as the regression over here, right? So once you have understood that, now we shall talk about the types of the regression, right? If we talk about the types of regression, so we shall talk about the types of regression. In the types, we are basically having the three category over here. One is the simple linear regression, second one is the multiple linear regression, and third one is the logistic regression. So first one I am talking about, I am starting with, that is the simple linear regression. Okay, simple linear regression. In the simple linear regression, we are saying that value of one variable, right, it could be y, it could be x, value of one variable is used to predict the another variable, right? Just now we have talked about that. So we are saying that value of one variable, that could be x, right, that could be x, is used to predict value of another variable, value of another variable, and that could be y, right? So I'll be using the value of y for the prediction of x. That is a simple thing. That's what simple linear regression says over here. And here we shall be using the regression equation. We shall be using the regression equation for the calculation of this particular simple linear regression, right? And what is that particular equation which we shall use? The equation over here is y equals a plus bx. That is very, very important equation, guys. Sometimes they are asking us direct question, y equals a plus bx, where we shall say that y is equal to, one would be the dependent variable, one would be the independent variable. So dependent variable means we want to calculate that, independent variable means we will be using that. So y will be dependent variable, x over here will be independent variable, right? A over here, that is the intercept or regression coefficient, intercept coefficient or regression coefficient. Okay, and b is the slope of curve. B is the slope of curve. I showed you the curve also in the correlation chapter. So slope of curve, or that might be called as the correlation of variables, or that might be called as the regression That might be called as the regression coefficient. Okay. Now A over here I told you it is not regression coefficient, sorry, that is the regression constant, right? That would be the regression constant. Okay. So these are the values if in case they are asking. However, they might be asking you only one thing over here, that y equals a plus bx is the equation which we are using for the simple linear regression. Value of one variable x might be known, might be predict by the uses of value of another variable, that is y, okay, or y or x, that can be used vice versa, right? So basically the term is that we can be using one variable to predict the value of another variable. That is the simple linear regression. Now we shall be talking about the multiple linear regression. Second one will be the multiple linear regression. Once you have understood the single linear regression, now it is very easy to understand what is multiple linear regression. Why is it so? Because in the multiple linear regression we are talking about, in the simple what I told you, one variable we are using to predict another variable. Here what I will be doing, that I will be using more than one variable. I might be using two variables, I might be using three variables to predict the value of another variable. Are you understanding? So to predict the value of this variable, and I am using only one variable, that is called a simple linear regression. If I am using different variables for the prediction of this variable, then it is the multiple linear regression. I hope that is making sense over here, that more than one variable, if I am using more than one variable, is used for prediction of another variable, and let's say that another variable is y. I want to predict the value of y, but for that I am using different variables, right? For an example, and this can be calculated by, here I will be writing the formula as, y equals, I told you for the simple one, a plus bx. Here I am writing a plus b1 x1, right, plus b2 x2. It depends on how many variables I am using. A and b, they are just constant. One is the regression constant, and another one is the regression coefficient, right? So like that we can write b and xn. So it depends on how many variables we are using. So like that, for example, two variables we are using, so b1 x1 plus b2 x2. If I am using five variables, b1 x1 plus b2 x2, and so on and so forth, right? So that is the thing over here. So this formula we shall be using for calculation of multiple linear regression. I hope you understood that, right? So simple linear regression, multiple linear regression. After that we shall be talking about the third one, that is the logistic regression, right? That is the logistic regression. In the logistic regression we are saying that, here the outcome basically, here the outcome will be qualitative. For example, this particular person will be developing the disease, or this particular person will not be developing the disease, or this particular person will be surviving or not surviving. For example, that particular person is sick, so this particular person will be surviving or not surviving, right? Somebody has been smoking for 20 years, so this person will be developing the any kind of respiratory problem or not, right? Some person is obese, this person will be developing the hypertension or not, this person will be developing the diabetes or not. So these are the outcomes. So these are the qualitative outcomes, guys, right? Here these are the countable outcomes, right? So they are talking about the qualitative here. So if the outcomes are qualitative, then it is called as the logistic regression. And if I am talking about the qualitative data, we shall be talking about which data scale? We shall be talking about the nominal and the ordinal data scale. So over here the outcome will be generally the qualitative data. It means the outcome will be generally either the nominal or the ordinal ones, right? So that is the thing over here. Here we are not talking about the quantitative data, right? We are not talking about some numbers over here. We are talking about the qualitative data. So here we shall write that outcomes will be generally nominal. Outcomes will be generally nominal, or it might be categorical. It might be categorical, but not the numerical, right? It might be nominal or it might be categorical one. It might be categorical one. Like some of the examples I shall mention over here. For example, about the death or survival, right? We never know, right? There is a natural death, and before that if something happens, there might be the trauma, there might be the accident, okay, and we never know, the person might be having the expiry, so due to some kind of accident or due to some kind of disaster, right? So that is the thing over here. So that is the outcome of death or survival. There is a risk factor, you know, the person is smoking, the person is obese, they will be developing the disease or not. So these kind of things, right? So disease, you know, the person will be developing the disease or not, plus or minus, right? So these are the some examples we can be taking for the outcomes over here. So that is the thing. So here I should say that outcomes, whichever they will be, right, they will be represented between 0 to 1, right? They will be represented between 0 to 1. For an example, you can see, right, what I can see over here. I can see that I have compared the linear regression with the logistic regression. So in the linear one, there is a simple line, you know, straight line over there. In the linear regression, there is a simple straight line, right? Here we will be using one variable to predict the another one, right? But in the logistic regression, what we are seeing that, you know, and we can see the predicted y can exceed the 0 and 1 range. So that was 0 and this was 1. So it can easily cross the range also. That is the linear regression. In the logistic regression, it is not crossing the range over here. It is, you know, there is a 1, this is 0. So it is always in between 0 and 1. And the curve you will be seeing over here, here you will be seeing the straight curve generally. And for the logistic one, you will be seeing the S-shaped curve. You will be seeing there will be the S-shaped curve, right? So there is a difference over here, and the predicted y will always be lying in between 0 and 1 range. Okay, that will always be lying in the 0 and 1 range. So that is the major difference between the linear regression and the logistic regression, right? So that was about the regression, where we have talked about 3 types over here, that is simple, linear, multiple linear, and the logistic regression, right? Thank you.